Okay, lesson 1.5, infinite limits. Please copy down the 4 functions and complete the warm-up. We'll talk about them in class tomorrow. Sketch the graph of each of these. Do not use a calculator. Alright, a couple definitions. An infinite limit is a limit that increases or decreases without bound. So an infinite limit is a limit that if it increases, it approaches positive infinity, or decreases, it approaches negative infinity. A vertical asymptote exists if the one-sided limit, either the limit as x approaches c from the left, or the limit as x approaches c from the right, has an infinite behavior, so it approaches positive or negative infinity. Now remember from lesson 1-2, infinity is not an answer for a limit. If a limit approaches infinity, we say the limit does not exist. But we talked about last lesson, one-sided limits, we can have positive or negative infinity as a solution because it describes the behavior of the function. So if either the limit from the left or the right increases or decreases without boundary, then x equals c, wherever the infinite limit occurs, is a vertical asymptote. So finding vertical asymptotes. Vertical asymptotes are a type of discontinuity. Where do discontinuities occur? We must first determine any domain restrictions. Okay, so we have a rational function. Let h of x be f of x divided by g of x. A vertical asymptote exists at c if, when we look at the function, f of c is a number that's not equal to 0 and g of c is equal to 0. Answer this for me for tomorrow. If f of c equals 0 and g of c equals 0. Alright? We'll talk about that tomorrow. Think about that and try and just determine a solution or an example for that. Okay, so if any of the graph of the function. Let's look at f of x equals 1 over x squared. So when attempting to determine vertical asymptotes, can equal 0, and then look at the one-sided limits. Limit as x approaches 0 from the left-hand side. Alright, so if we think of 0 on the number line, a number to the left of 0, if we pick negative 0.1 and I plug it in here, the numerator would be a positive number, the denominator would be a positive number, so the limit would approach 0 or positive infinity. Excuse me. Limit as x approaches 0 from the right hand side. If we pick 0.1, looking at it into the function, numerator will always be positive. 0.1 squared would give us a positive number. So the right side limit would also approach positive infinity. Therefore, there's a vertical asymptote at x is equal to 0. The asymptote is going to occur at the domain restriction as long as the one-sided limits have the infinite behavior. G of t equals t minus 1 all over t squared plus 1. When we look at to determine the domain of a rational function, t squared plus 1, will that ever equal 0? If we attempt to solve that equation, t squared would never equal 1. The domain is all numbers, therefore no vertical asymptote. We like problems like that. Minus 2. So before even attempting to determine the domain domain, let's simplify the expression at all. Numerator is not the difference of perfect squares, so we'll leave it as is. The denominator factors into x minus 2 times x plus 1. So the domain, x can't equal 2, x can't equal negative 1. So we have to look at the one-sided limits of both of these values. So at x is equal to 2, limit as x approaches 2 from the left-hand side of h of x, and limit as x approaches 2 from the right-hand side of h of x. So if we pick a number really close to 2 on the left-hand side, let's say 1.9, in the numerator, 1.9 squared minus 2 would be a positive value. 1.9 minus 2 would be a negative factor there, and then a positive factor with, for x plus 1. So this will give me a limit of negative infinity. So instead of trying to determine in your head 1.9 squared minus 1.9 minus 2, use the factor form. That's why we start by factoring. 2 from the right, 2.1 squared minus 2, that would give me a positive value. 2.1 minus 2 is a positive, times another positive. So from the right-hand side of 2, the limit would approach positive infinity. Therefore, vertical asymptote at x is equal to 2. Now for negative 1, limit as x approaches negative 1 from the left, limit as x approaches negative 1 from the right. Alright, so negative 1 from the left, if we square, so negative, if I think to the negative, we'll plug in negative 1.1, and to the right of negative 1, we'll plug in negative 0.9. So negative 1.1 squared minus 2 would give me a negative value. Negative 1.1 minus 2 would give me a negative, times negative 1.1 plus 1 would give me another negative. So this would approach negative infinity from the left. Negative 0.9 squared minus 2 would give me a negative value in the numerator. Negative 0.9 minus 2, that would give me a negative, times a positive for negative 0.9 plus 1. So this would approach positive infinity. Therefore, vertical asymptote at x is equal to negative 1. You do have to show that the one-sided limits have the infinite behavior before you conclude that a vertical asymptote exists. Alright. F of x equals x cubed plus 1 all over x plus 1. Okay, so we're simplifying first. The numerator is the perfect cube. Square the first, change the operation. So minus the product of the two terms plus the second term. Now from here, we have a domain restriction. So before we cancel, there is a domain restriction from the original. The domain is that x can't equal negative 1. When we look at the factored form, though, these sorry about that. These x plus 1s cancel each other out. So when we attempt to find the limit, direct substitution into negative 1 squared is 1 minus negative 1. So since the limit exists, what is it? At the point negative 1, 3 on the graph. So remember, when the limit exists, it's a removable discontinuity, not a non-removable discontinuity. And you'll be practicing these in class as well. Alright, now let's find the limit, if it exists. limit as x approaches 1 from the left-hand side. So when you attempt to determine one-sided limits, if a one-sided limit exists, always start with a direct substitution. So if I found the limit as x approached 1, direct substitution would give me negative 1 over 0. So automatically the limit does not exist. Furthermore, since the numerator is not 0 and the denominator is 0, I know that there should be a vertical asymptote at x is equal to 1. So my one-sided limit is either going to approach positive or negative infinity. So now when we look at a value to the left of 1, it's 0.9, I'll always have a negative numerator and I'll always have a positive denominator. So for one-sided limits, you can have negative or positive infinity as an answer. So negative infinity would be the solution for that. Limit as x approaches 1 from the right-hand side, 2 plus x over 1 minus x. So again, direct substitution, limit as x approaches 1 of the function would give me 3 over 0. So I know there's a vertical asymptote at x is equal to 1. So now just looking at the behavior, 1.1 plus 2, that would give me a positive, over 1.1 minus, or 1 minus 1.1 would be a negative. So I have negative there as well. Okay, limit as x approaches negative 1/2 from the right-hand side. 6x minus 1 all over 4x squared minus 4x minus 3. Now instead of going right to a direct substitution, I would recommend that you factor this and see if we can get anything to cancel. Alright, so you want to simplify your life by any means possible. Negative 6 and positive 1. 3 minus 2 is 1. 3 times negative 2 is negative 6. Negative 12 and negative 4. Negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. So the top would factor to 2x plus 1 times 3x minus 1. And then the bottom will factor to 2x minus 3 times 2x plus 1. So now from here, the 2x plus 1's cancel each other out. The negative 1/2, the value of negative 1/2, is what would have made on direct substitution the indeterminate form of 0 over 0. Since we canceled that factor out in the top and bottom, now the one-sided limit is just going to be a direct substitution into the simplified function. 2 times negative 1/2 would be negative 1 minus 3. My numerator would give me negative 5/2 all over negative 4. So negative 5 over negative 8. All that work for 5/8 as an answer. Alright, let's look at what number is this? So our last one, limit as x approaches 0 from the left-hand side of x squared minus 1x. When we look at that, 0 is going to be a domain restriction here. So let's make this into one expression, getting a common denominator. So we have x cubed minus 1. Okay? Now this is the difference of perfect cubes, but x minus 1 is the factor, not x, so it won't do any good. So direct substitution would give us negative 1 over 0, so we know there's a vertical asymptote at x is equal to 0. We just need to determine, is it positive or negative infinity? So if we choose negative 0.9, when I cube that it gives me a negative, and then on the bottom it'll be a negative. So the behavior of the function is that it would approach positive infinity. All right, see you tomorrow.